Ladies and gentlemen, please give a warm waves welcome to the 8th president of Pepperdine University, Jim Gash.
Thank you. Thank you and welcome to the Lisa Smith Wengler Center for the Arts. And I've got a surprise for you. Guess who's with us tonight? Lisa Smith Wengler. Lisa, can you stand to be recognized? Lisa's here with her husband, Morton. Thank you guys for coming. And thank you to all of you for coming. About 8 months ago, when I got the call that the next presidency would be my responsibility, I decided I needed to start this week with two really important things. First, giving honor to whom honor is due with the worship and praise last night. Thank you for coming to that, those of you who are here. And then we wanted to go deep into academics, because Pepperdine is a deeply academically excellent institution. I asked the team, led by Lee Katz, find somebody with a world-class scholarly record, with a global impact with her work, and someone with earth-shattering faith, to talk about the intersection between faith and academia, between science and God. And they brought me someone even better than I had hoped. Jennifer Wiseman, who will be introduced momentarily, spent the entire day with our students today because she wanted to be with us. She is someone who is a world-leading astronomer, someone who cares deeply about the intersection of faith and science. So to introduce our guest, Jennifer Wiseman, please welcome Seaver Professor Jane Gansky.
Thank you, President Gash. It gives me great pleasure this evening to introduce our inaugural speaker, Dr. Jennifer Wiseman, an astronomer and astrophysicist. Dr. Wiseman grew up in northern Arkansas in the Ozarks, far from city lights, and she enjoyed stargazing, oftentimes exploring the natural world with her family and pets. Her parents encouraged her to really pursue her dreams, and as a first-generation college student, she enrolled in Harvard University studying physics. It was there that she first engaged in undergraduate research during a time when it was really quite uncommon at a major university to do undergraduate research in the sciences, particularly as a woman in physics. But it was during these years that she had the opportunity to actually do some field investigations. And in 1987, she was on a field investigation at Lowell Observatory in Arizona, in Flagstaff, where she had a major scientific breakthrough as an undergraduate. She discovered a comet named the Wiseman-Skiff comet. And I think this dramatic discovery probably played a role in the fact that she chose then to pursue graduate research at Harvard in astronomy. Following this, she continued her research as a Jansky Fellow at the National Radio Astronomy Observatory and as a Hubble Fellow at the Johns Hopkins University. She then served as a Congressional Science Fellow of the American Physical Society, working with the staff of the Science Committee of the U.S. House of Representatives. She is now a senior astrophysicist at NASA. Dr. Wiseman is a fellow of the American Scientific Affiliation, a network of Christians in science, and she lectures to a variety of public groups on a myriad of topics, including faith and science. It seems fitting that Pepperdine's inaugural week celebrating President Gash includes astronomy and astrophysics, two fields that have seen dramatic discoveries in the past few years and really a new vision in the past decade. Dr. Wiseman's own research on star and planet formation offers a unique perspective of being able to glimpse into the heavens, considering both the origin and future of our galaxy and galaxies beyond. Modern astronomers and astrophysicists rely on the work of Galileo, considered to be the father of observational science, and also the theories of Max Planck, considered to be the originator of quantum mechanics. These two scientific greats lived years apart, 300 years apart, yet both maintained that there is nothing incongruent between science and religion. In fact, Max Planck was quoted as saying, "There can never be any real opposition between religion and science, for one is the complement of the other. Every serious and reflective person realizes that the religious element in his nature must be recognized and cultivated if all the powers of the human soul are to act together in perfect balance and harmony." As a chemist, it's humbling for me to consider, as I teach freshmen about the periodic table of the elements, that these elements originated from our stars. Magnificent stellar ovens, so to speak, that created the oxygen in our atmosphere, the iron, the silicon in our rocks, and even the calcium in our bones. A star's color, and you'll see some magnificent stars' colors this evening, stars' colors and their spectral lines actually give us clues about their elemental composition and temperature. And these are examples of both beautiful and scientific reflections, I think, of God's handiwork. As we consider the vastness of our universe tonight, Dr. Wiseman offers a multifaceted vision into scientific inquiry and our response to such an awe-inspiring creation. The title of her lecture this evening is A Universe of Wonder, Challenge, and Possibility. Please join me in welcoming Dr. Wiseman to the podium. Thank you very much.
Good evening. I am very honored to be here at Pepperdine. I've traveled across the continent to get here, and it's very refreshing to see your ocean, your beautiful views, and your beautiful people. So thank you for inviting me here, and congratulations, President Gash. Where are you? There you are, yes. On your appointment. And so I'm honored to celebrate with you and with the entire Pepperdine community today. So we are going to explore together a little bit of what we're discovering in the universe and how it can inspire us. I was asked to come and give a talk in 45 minutes that covers everything about the universe and that is also relevant to students of every major here and also people in the schools of law, education, business, policy. So I've never had quite a challenge like this, but we are all part of the universe, so that connects us to begin with, and we'll try to touch on some of these many topics. I'm also going to talk about how science and technology in general are inspiring new possibilities and new challenges as we move into a future very quickly that is driven by science and technology. So let's start with thinking a little bit about the universe we live in and what we're learning about it. So I do believe that we live in a universe of wonder, challenge, and possibility, and beauty. Here is a region in our galaxy where stars are still forming. One thing that people often don't think about is that our universe is active, not static. There's a lot of activity out there in the universe, and we're starting to uncover more and more of that with our telescopes as the technology improves over time. In regions like this that are scattered around our galaxy, we see these nebulous clouds of gas and dust. These clouds are turbulent. They're pretty wispy, most of them, but we can get pockets of gas within that turbulence, eddies that are quite dense relative to their surroundings. And if you get enough material in the small enough volume, the gravitational pull of this material will overcome the turbulence and you'll get a collapsing ball of gas. And if there's enough material in that collapsing ball of gas, the pressure will be very great in the middle, enough to spark a reaction called fusion, where hydrogen atoms, most of the gas is hydrogen, will fuse together in a series of reactions that produces helium and other products and also produces light. And that light eventually makes its way out of the surface of this sphere of gas. And that's what we call a star. So stars are basically little factories where hydrogen is being fused into heavier elements, light is being released. When stars form, they also release winds that can go out and help drive away the surrounding gas and dust that's remaining in that nebula out of which they formed. So here's a region where you have a whole cluster of big, massive stars that have formed. And it's pretty relatively young because the winds and the gas from those stars have not yet had a chance to blow away all the gas from the surrounding nebula out of which they formed. So you see a combination. The gas is lit up into beautiful colors because these massive stars have radiation that's powerful enough to hit the atoms of gas and temporarily separate the electrons from the nucleus of the atom. And when those atoms recombine, visible light is produced. So a nebula that's lit up like this to astronomers is also evidence of recent star formation and active star formation because it hasn't been enough time for the gas to be blown away. It's also a sign of great beauty. So with our telescopes, we're learning much more about the activity of the universe, and I think also inspired much by the beauty in the universe. How are we able to do this? Well, it's with our tools, our technology tools that have improved over the years. Here I am with a model of the Hubble Space Telescope. This is a space telescope, as many of you know, that's orbiting the Earth. Behind me is an image of the Whirlpool Galaxy as imaged with the Hubble Space Telescope. I love space, I love astronomy. I'm grateful to be a part of this enterprise of studying the heavens with telescopes. But I did not grow up thinking about becoming a scientist, or I didn't even know any scientists. I just knew about the natural world. I grew up on a farm in north central Arkansas, and these were my neighbors that I like to point out that I'm the one in the middle. The neighbors were our cattle that we fed. This is a cold winter day in January, so we had snow and very cold temperatures. I grew up being able to wander the meadows and the forests and the streams on the farm and really enjoy the natural world. And at night, the sky was dark. Have any of you ever been to a really dark night sky place? I hope so. When you can see the night sky, it is very awe-inspiring if you can see stars. And it's too bad that in recent decades, most of the people around the world aren't able to see stars as well as we could in all the centuries past because of the light pollution that we're allowing to fill the glow of the night sky. But I was able to think about space a lot growing up, just wondering what it would be like to explore up there. And I was also privileged when I was growing up to learn about the first images from probes called the Voyager probes that had been sent out into the solar system by NASA to take images of the planets around other stars for the first time and send back those images. And I was fascinated by these alien worlds, moons like Europa around Jupiter that are covered with ice, and yet we think there's a liquid water ocean under that ice. Or Io, this weird moon that's got volcanoes going off right and left. All kinds of interesting places. I wanted to be a part of this enterprise. Also, the Star Wars movies were coming out. We were all thinking about space. And I didn't quite know how to be involved in this enterprise of space exploration, whether to try to be an engineer or an astronomer, or I didn't know any scientists, but at least I had encouraging people in my family, and my parents were not able to go to college themselves, but they were very keen on making sure that their kids had that experience. So I'm a first-generation college graduate in my family, And even though we didn't have a university nearby, we had a lot of respect for education in my school. My teachers were very encouraging for us to just go for it, try for whatever we might be curious to do. And my church was very encouraging. We didn't know much about formal science, but we believed that all of creation is God's handiwork. And so certainly the study of nature is glorifying to God. It would be studying God's handiwork. So I'm thankful that I was able to go on and just try different things that I didn't know where it would lead, but I went on to study physics and later astronomy in university. So how are we studying the universe? Well, we use different kinds of tools. So here's some examples of these different types of telescopes. And we need different kinds of telescopes to give us the full picture, because no one telescope can see all the wavelengths or colors of light, all the electromagnetic spectrum. No one telescope has exactly the right field of view that we need for different types of observations. So these are some examples of the different instruments we use. On the top is the Hubble Space Telescope. It's one of several. There are other space telescopes as well, but this is the most famous one. It is operating right now. It's very healthy right now. And it is orbiting the planet Earth, which you can see down below it. It's not very far from Earth, so we don't actually send the telescope far off into space. It's pretty close by, and the reason it's up there is just to get it above the atmosphere so that the images are not blurred by our atmosphere, and some wavelengths of light are actually filtered out by our atmosphere. So to get the clearest, sharpest images, putting telescopes on mountaintops or even into space is the best way to go. It's about the size of a school bus, and it's whizzing around the Earth every 90 minutes. So by the end of this event tonight, the Hubble telescope will have gone all the way around the Earth, and yet its pointing is very stable because clever engineers have built gyroscopes and other mechanisms to keep the telescope quite stable. On the lower right is a different type of observatory. It's an array of radio telescopes in South America. These are able to peer into wavelengths of radiation that the Hubble telescope cannot see. These telescopes see radio waves, or what we call millimeter and submillimeter wavelengths of light, which are really good if you want to look in these dense clouds of interstellar gas and dust, because a lot of that material, while it blocks visible light, it radiates in these other types of light. And on the lower left are examples of optical and infrared telescopes on the ground. We can do things with telescopes on the ground that we can't do so easily with space telescopes, like get wide fields of view or spend a lot of time observing something. So these are the Keck telescopes on the top of what we hope is a dormant volcano in Hawaii. But again, high and dry are what we like to get for our telescopes. And we like to, I like to think of telescopes or astronomy in general is like a symphony orchestra where the different telescopes represent kind of like different instruments in an orchestra. And so the conductor will call out some music from the trumpets and some from the violins and some from the flutes and some from the percussion. But all together, you need all of those contributions to get the full piece of beautiful music. Well, to understand fully what we're studying, whether it's stars or planets or galaxies, we need information from all these different types of telescopes working together in concert. This particular telescope was enabled by the work not only of astronomers, but of engineers and technicians and policymakers and politicians and international agencies and, of course, the taxpayers. And it was put into orbit by the space shuttle. So this was a marvelous cooperative effort between engineers, scientists, astronauts, and the whole spacefaring community. So this is the crew of astronauts that went up for the final time 10 years ago to service the Hubble Space Telescope. The space shuttle is no longer operating now while NASA is preparing a more powerful vehicle to take humans back to the moon and eventually to Mars. But in this interim time, we wanted to make sure that the astronauts left Hubble in really good shape, and they did. So 10 years ago, they did a marvelous servicing mission. They went back to the Hubble telescope, orbited along with Hubble around the Earth for a few days. The astronauts went out in their spacesuits and took out old instruments like cameras and put in new ones, and also repaired some instrumentation, and they did a wonderful job. So the Hubble telescope is operating very well right now, and I'm glad to say that. Now, one of these astronauts was an astronomer, and he brought with him an interesting item. So here is the cockpit of the space shuttle, and through the window in the back, you can see the Hubble Space Telescope. It was, for those days, attached in the cargo bay of the space shuttle while they were doing work on it. And in the front, this thing is a model of Galileo's telescope from 400 years ago. Now, Galileo was the first person that we know of who used a telescope to take recorded observations of what he saw in the night sky. And so it was really interesting to see these two telescopes kind of juxtaposed over one another, showing how 400 years of development of optical technology has increased our view of the universe in a spectacular way, but all started by a very innovative use of technology in the first place. So technology can be used for many different things, good or bad. But in this case, I think technology has been used for something very good to inspire and enable progress in science and discovery, and also astronomy and other sciences inspire other human reflection, whether that's theology or philosophy or art or poetry. Our discoveries enlarge our contemplations in many different directions. So some of these images are a product of the Hubble Space Telescope and other telescopes, and I believe they are inspiring. Here's one of my favorites. It's another one of these star-forming nebulae where the cluster of massive stars there is lighting up the surrounding gas. The telescope has filters that allow it to perceive some of these different colors of gas that are being lit up. So I believe that we live in an incredible universe that inspires wonder and awe, both on the large scale, as I'm showing you tonight, and on the small scale too. Other sciences are revealing new knowledge and discoveries that should give us a sense of humility and wonder and awe. So speaking of stars, here's a bunch of them, all right? This is the core of a very dense community of stars. It's a globular cluster in our own Milky Way galaxy. Now, our sun is a star, kind of like one of the smaller ones in this group, but we don't live in such a crowded neighborhood. This neighborhood is several times more crowded than the neighborhood around our sun. But it's beautiful, right? I consider this like a collection of gemstones, and you can see just by looking at this that stars are not all the same. Some of them are bigger and brighter, some of them are smaller. Now in astronomy, we never know if something looks brighter. We don't know easily whether that's just because it's closer or whether it truly is intrinsically brighter than something else. In this case, all these stars are more or less the same distance because they're part of the same cluster. So the brighter looking stars really are brighter. And the different colors of stars represent different temperatures in their outer atmospheres. So I asked the students today, when I gave a lecture at noontime today, which of these stars do you think are the hottest stars? And they got it right. So I'd like to ask this audience, which ones do you think are the hottest stars? How many say blue? How many say red? The blues got it. Okay. But they're all hot, they're all stars, okay? Now, you get extra credit tonight if you come back and tell your professor which New Testament verse says that star differs from star in splendor, okay? Now, this is beautiful and awesome, but it's really hard to understand the context of this image, so that's why we do need different kinds of telescopes. So let's zoom out now to a wider field of view, looking with a different kind of telescope, a telescope on the ground that's looking toward the center of our own galaxy. And our star is in kind of the outskirts of the Milky Way galaxy. And as we look toward the center of our galaxy, you see a lot of dust and gas. That's kind of that stuff down in the lower left. And a lot of stars. It's crowded. And some of these objects that look like stars, bright stars, are actually whole clusters of stars. So we're going to zoom in from this big picture view to one of these objects and then transition over to the Hubble Space Telescope view, which isn't able to get this big field of view, but it's able to get much more detail in a small field of view. So let's see the change of perspective here. So this is the Centaurus constellation. We're zooming in now on one of these objects that looked like a star, but now we see that it's actually a dense cluster of stars. And then as we zoom in, we're transitioning over to the Hubble Space Telescope image, which shows us that image that you saw before. So it helps to see things in context, doesn't it? I mean, that's true for a lot of things in life. Would you like to see that again? Okay, all right. I just don't want anyone to get seasick here. Okay, so I don't like this violent constellation, but it's not my fault. Okay, so here's Centaurus. And zooming into this object, which we now see as a globular cluster. By the way, globular clusters are the oldest things in the galaxy. They're the oldest stars. But we move in and transition over, and with a good telescope, you can resolve star from star and see this beauty. If you were to look at this cluster with a telescope under the atmosphere on the ground, most telescopes would simply see a kind of smudge of light because all the light would kind of blend together. So getting resolution and getting this pristine sharpness really helps us to understand. And scientists can then take stars individually here and look at their compositions, look at them with spectroscopy and see what they're composed of. This is the Orion Nebula, a region of star formation that I have studied many years for my own doctoral and postdoctoral research. It's another one of these regions where massive stars have coalesced out of this dense gas, and they are ionizing the surrounding leftover gas into these beautiful colors. But behind this, which is dark, you can detect with radio telescopes a much larger region where stars are still forming. It takes longer for lower mass stars to form. And so you see them heating up. They're called protostars. And it's a very active and interesting region that you can see different parts of with different kinds of eyes. These clouds of gas and dust fill the volume of what we call galaxies. So this is a galaxy. It's just a random sample that I pulled out of the archive of Hubble Space Telescope images, but I think it's particularly beautiful. Galaxies, the volume of them is filled with gas and dust and a large amount of what we call dark matter, which doesn't show up, but we know it's there because we see its gravitational pull. But it's also filled with stars, and so the starlight here is very apparent. There's so many stars in the core of this galaxy that the light all blends together. And over time, these galaxies are rotating. They'll take on these spiral structures. We think our own Milky Way looks something like this, where our sun would be along close to one of those spiral arms, about 2/3 of the way out, and our planet and the other planets in our solar system are just orbiting around that one star. But there are probably something like at least 300 to 400 billion stars in this galaxy alone. And if you look carefully, you can see some other galaxies in the background of this image. Now, I find this so strikingly beautiful that I'm not surprised that astronomers named it NGC 1309, because it just grips the soul. Which brings us into how scientific discovery does inspire. So here's a quote from Immanuel Kant. I believe it is on his tombstone, translated here into English, where he said that two things filled his mind with ever-increasing wonder and awe, the more often and the more intensely he reflected on them. So those two things that just kept increasing his sense of wonder and awe were the starry heavens above him and the moral law within him. Now, isn't that amazing? You know, the two things he thought about that continued to inspire him with wonder and awe are the starry heavens above him and the moral law within him. And you think about that, even today in our society, the heavens really get people interested and inspired. And I would say beyond that, scientific discovery in general is of great interest to people. But people are also interested in the moral law, even if they don't call it that. But we're all interested in justice, or we should be. Or around the world, you know, who gets to make decisions of what's right and wrong, and how do we know there's such a thing of right and wrong? C.S. Lewis was partly brought to his Christian faith when he was musing on the fact that everybody has some sense that there's a right and a wrong, and a just and an unjust. They don't all have exactly the same package of that, but there is some sense that there's a moral law. So, new technologies, such as optics, enable new scientific discoveries and advances. And then this new scientific understanding spawns new questions and brings new depth to old questions. And I'll give some examples of this. Well, one quickly is that we've wondered for as long as humans have been recording their thoughts whether there's life beyond Earth. But our new discoveries that there are plenty of planets around other stars is reigniting this question of could there be life beyond Earth, and how would we find it, and what would it be like, and what would it mean scientifically, but also philosophically and theologically if we do or don't find life beyond Earth. So what are some other examples? What are some examples of these new discoveries and advances that feed or spawn these deeper questions, especially questions of how we see ourselves as humans and how we fit into the bigger picture of the universe? So I have pulled some random examples. These are purposely meant to be disparate, to not actually closely relate to one another, but I want to give you some examples of new discoveries that are invigorating these deeper questions of what does it mean to be human. First of all, as I mentioned, in astronomy, we're discovering that there are lots of planets outside our solar system. Now, when I was in college, we didn't know of any planets other than the ones that orbited our sun. Now, we imagined that there might be planets elsewhere, but we didn't have the technology to actually detect them. Along about the time I was in graduate school, these detections, very disputed and indirect at first, but they started to take place. And now our telescopes have become better and better to the point where we have discovered thousands of planetary systems outside of our own solar system, many of them with a different space telescope called the Kepler Space Telescope. And now we're rushing to use the telescopes we have and also to design future telescopes so that they can tell us something about the nature of these exoplanets. That's what they're called, exoplanets. They're outside of our solar system. And so we can address the question, are there other planets in the universe? Well, now we know the answer is yes. Is there another Earth out there? What are these planets like? Is there life out there beyond Earth? We don't know the answer to that yet, but we're building telescopes that should be able to tell us whether any or many of these planets are at least habitable, and we're making progress just about every day. We just announced a few days ago that an exoplanet has been found in the habitable zone of its parent star, meaning it's not too close to be too hot and not too far away to be too cold, have liquid water. And we see water vapor in the atmosphere of that planet in the habitable zone of its parent star. That's the first time we've seen water vapor in a habitable zone planet. Doesn't mean there's necessarily life there, and we don't know enough to know whether that planet has a solid surface, but you see progress is being made. So this is an old question. Thousands of years ago, Greek philosophers were speculating about life in other worlds. Here's Epicurus saying, there are infinite worlds, both like and unlike this world of ours. We must believe that in all worlds there are living creatures and planets and other things we see in this world. And of course, I grew up watching Star Trek and Star Wars, so we've imagined this in all kinds of ways. But the difference is that now we're actually pulling data We haven't found life yet beyond Earth, but we're finding these exoplanets, and it's spurring on not only more scientific discovery, but it's reigniting the questions of what would it mean if we find life beyond Earth? Does that mean we are less significant? What does that mean theologically? As Christians, what's the relationship of life on planet Earth if there's life elsewhere? How does God relate to them? This is a real system of planets, but it's an artist's conception because these planets were discovered orbiting a star using the Kepler telescope to look at what we call transits. By staring at the star and seeing it dim a little bit periodically, you can tell if there are planets orbiting in front of it. All right, how about a different example? The human microbiome. Are you all familiar with that term? I hope some of you are, the biologists. Our bodies, it turns out, contain a lot of other creatures. All right, doesn't that feel good? So your body includes something like 10 to 100 trillion microbiota cohabiting within you. And I read different estimates. So those of you who are professors in biology here and students, forgive me because I really don't know what I'm talking about. But I understand that there's at least the number of cells in our body that don't have our DNA as there are that do. So we're actually little walking communities, all right? So that has both philosophical and practical ramifications. The philosophical one is, who are you? Are you an individual or are you a community? And what does that mean theologically? Am I one creature before God or am I a whole community? Am I responsible for the well-being of the other creatures inside me? Are they responsible for me? What does it mean to be human if it requires that we have this cooperative biology? It also has practical implications. It turns out that our diets and the medicines that we take in our environment can impact this microbiome inside us, and that affects our mental health, our physical health, all kinds of things about our well-being. So we need to understand this interaction between the community within us and the environment outside of us. A lot of research in this area. All right, another whole area, the human and machine interface. Well, it used to be clear what's a human and what's a machine, but not so much right now. The lines are blurring. In some sense, for good, we're learning how to help humans who have challenges to be able to perform better with mechanistic devices, but you all know that it's getting kind of crazy. Many of us, our brains are merging with our smartphones. And the whole artificial intelligence movement is growing and growing. I found interesting today a whole website created by a thoughtful group thinking about artificial intelligence in Christian thought and practice. What are the ramifications of AI, and what does it mean? How do we distinguish artificial intelligence from human intelligence? And of course, AI is being created by humans, so what is it of our perspectives and even biases that's being built into the artificial intelligence that we may be relating to in more sophisticated ways over the years? So here's some of the example articles I found on this website that involves the ethical and even missional purposes of places like Pepperdine as you think more fully about your interactions with the globe in coming years, including things like machine consciousness or finance, charity, and fairness, or relating to artificial persons, how AI is changing global understanding and cooperation. So artificial intelligence is a huge topic, computationally and practically. Ethics are having to be built in machines. How about self-driving cars? Are you going to teach a car what to do if it has to choose between running into a group of people and saving one, or swerving to miss the group of people when you know it's going to kill one on the side? I mean, these are these classical ethical dilemmas, but if you have to program something to do that, think about drones and things like that. How do you do that? And what happens, our human fallibility suddenly gets programmed into our artificial intelligence and machines. There are other issues that are interesting cropping up. The brain, what exactly is the brain? What's the difference between the brain and the mind? And theologically, we can also think about how does that relate to soul and spirit. But brain and mind is a hot topic, and lately there's been some stir as to when is the brain actually dead? When is a person actually dead? We've been saying for a long time that when brain activity ceases, that's kind of the definition of death. Well, recently, a pig brain that was dead was revived. And so does that mean that the pig was never actually dead? So there's lots of interesting questions coming along. What about our environment, ecology? We know that our Earth's environment is changing rapidly. And of course, there's a lot of politics in these conversations going on these days, but nevertheless, we need to prepare for whatever tomorrow's Earth is going to be in terms of population, in terms of the environment, in terms of changing climate. What should we be doing now, and how can we be good stewards of what we have now, our energy sources, the way we use energy, the way we use other resources that will be preparing ourselves for tomorrow's Earth. And are we doing now what we really want to do to create an Earth in the future that people will be able to thrive on? So a lot of thinking needs to be done today about good stewardship of planet Earth as we think about tomorrow's Earth and who will live there. All right, another example, neuroscience. And the question, am I only my brain? So we're learning much more and more about the brain itself, and a lot of people think, well, my brain made me do it. I helped sponsor a talk once that was called, Did My Brain Make Me Do It? The ethics of neuroscience or neuroethics. But this is not just a clever question. There's a question in the law, legal systems of how much can we actually blame someone for their actions if they're simply acting upon their brain chemistry, all right? What about genetics? We now know how to describe the human genome in ways we've never been able to before. We've mapped the human genome. It's wonderful, but am I only my genes? Is my whole aspect of me as an individual simply prescribed by my genetic code? And you see these inflated news stories sometimes, like they've identified the gene for this behavior or that one. So I'm sure that my gene for chocolate loving is very pronounced. But how much of that really defines us? Certainly our environment helps shape us as well. What's the trade-off there? And how much are we responsible for our actions if we're genetically pre-programmed for certain things? And now we have a new ethical dilemma, which is we can edit genes. We can actually go in and change someone's genetic code. Is this wonderful or is it terrible? In some sense, it's wonderful. We can transform biology. We may have a chance to actually stop hereditary diseases that cause so much pain and suffering in so many people. We can relieve people of conditions that would otherwise hamper or end their lives. So we can, in some sense, praise God that we can edit genes. But if you can change someone's genetic code, especially in a way that's inheritable down the line to future generations, this is incredibly dangerous. We don't know if we tweak the genome over here that it might have some unintended impact on our genetic makeup over here. We don't know all these intricate interconnections. It is probably not a good idea to start editing genes right and left when we don't know exactly what the ramifications are. So not too long ago, a scientist in China edited the genes of a pair of twin girls so that they would be resistant to HIV. Isn't that wonderful? What a wonderful thing to do. In fact, some would say it would be unethical not to do such things like this if we have the technology. But that wasn't the reaction from people like Francis Collins, who is the head of the National Institutes of Health. He said, and he's normally a very calm and measured kind of guy, his reaction was pretty profound. He said the fallout from this technology, which is called CRISPR, this gene editing that was actually carried out on these twin babies. He said that this was a profoundly unfortunate, ill-considered, epic scientific misadventure that flouted international ethical norms and was largely carried out in secret with utterly unconvincing justifications. Okay, so our technology is zooming ahead before the rest of us, ethicists, theologians, religious communities, scientists in general, have a chance to ponder the ethical ramifications of some of this work. And so that is something that we need to grapple with as we move forward into a future that's being driven largely by technology. By the way, Dr. Collins is also a devout Christian, and he's written a wonderful book called The Language of God, where he talks about the beauty of the human genome. He calls it God's instruction book for the human body. And he also talks about what drew him to faith in Christ as a young adult scientist and physician. And so I recommend you read his book. He's founded an organization called BioLogos, which looks into the harmony of science and Christian faith. They have a good website, too. All right, another example, back to astronomy. Our whole universe, now that we have such good telescopes, we can look farther and farther out, which is like looking farther back in time, because it takes time for the light to get to us from more and more distant galaxies. So we can see how the universe changes over time. And that's very interesting. I'll show you a little bit more of that soon. So all kinds of questions coming up where science, technology, philosophy, and even theology and ethics, they start to touch one another. Here's a whole bunch of them I'll just throw out to you. This is some slides from the AAAS Science Organization, the Dialogue on Science, Ethics, and Religion program that I direct under the umbrella of AAAS. These are some of the questions we get. Are we truly affecting the planet's temperature, and what should we do about this? Or how big is the universe? Or could there be life on other planets? Or what's our relationship to this planet? What's the purpose of the universe? What does it mean to be human? What separates us from animals? What does science tell me about being human? What do religious texts tell me about being human? What do scientists know about human origins? What does neuroscience say about who I am? Is love merely a chemical process? Is there such a thing as a science of prayer? Do my thoughts determine my actions, or do my actions determine my thoughts? Can theology and science come to complementary conclusions? Our panel tonight, we're going to answer all those questions, all right? Science and technology are influencing and shaping nearly every aspect of our modern life. So if a university wants to be relevant to modern life, we need to be addressing the impact of science and technology on everything we are and everything we want to do. If a religious community wants to be relevant to modern life, better think about how science and technology impact every part of modern life, even mission work, things of that nature, contemplations of who we are. And furthermore, today's challenges and opportunities are interconnected with science and technology, and interconnecting many different fields more than ever before. So here's just some examples that come to mind, and I apologize in advance that I did not list every relevant field and discipline here, but maybe our panel will discuss these kinds of things. But for example, studies of the brain and behavior involve science and health and the law, such as our responsibility for one's actions. Legal courts now often bring in neuroscientists to testify when they're trying to understand whether someone is responsible for the behavior they have done. Artificial intelligence involves, of course, computer science, but also education, law, again, business, technology, and of course, philosophy, ethics. Space exploration involves engineering, science, law, business, policy, education, and more. And I would contend writing and arts and music even. Environmental challenges involve science, policy, business, education, law, et cetera, et cetera. Business has an international scope and impact on people around the world, financially and environmentally. So these are just examples of how our disciplines all interconnect now in very interesting ways. Even astronomy pulls in now biologists, chemists, geologists, physicists, computer science experts, and of course managers and project managers and communicators, all kinds of people we need in my field. That final bullet that I mentioned to you about the universe developing and changing, well, let me show you a little bit more about that as we circle back. My favorite image from the Hubble Space Telescope is what we call the Hubble Deep Field. And this was an image taken by pointing the telescope in a direction of the sky where there weren't very many stars nearby to kind of drown out the image. And we just collected light for several days to see what faint things would show up in the exposure. And the result was this, okay? So this is what's called the ultra deep field. This is an area of the sky just about the width of a drinking straw, so not very big. But all these little dots here, these are not stars. There's a couple of stars in here that are in the foreground, but by and large, the other little dots and smudges of light here are outside of our own galaxy. They are other galaxies, even the little tiny dots. These are all galaxies like our Milky Way. Well, some of them like our Milky Way, some of them a bit different, but all of them containing billions of stars. If our Milky Way were in this image and we were far away looking back at it, it would look like one of these little spiral objects like in the upper left there. Each one of these, even the little tiny things containing billions of stars, hundreds of billions of stars, and if they're anything like our Milky Way, each of those stars on average has a planet. And now imagine this extrapolated around the whole sky. So any direction you look in the sky, we've discovered you see something like this, a collection of galaxies. This is the universe we live in. It's unfathomable, all right? The number of galaxies, the numbers of stars, and they're not all at the same distance, right? Astronomy is a time machine, so some of these galaxies are farther away than others. And when we study them, we can tell how distant they are, and we can study their compositions, and we find out that galaxies change over time. So if we pull out these galaxies and kind of line them up by their distances, which means we're seeing the more distant ones as they were at an earlier stage of their development because it's taken more time for that light to get to us. Some of them are millions of light years away from us. A light year is the distance that light travels in a year. So the ones on the left are the closer galaxies, and some of those are millions of light years away. As we move to the right, those are galaxies that are farther away, and some of them are billions of light years away. So we're seeing them as they were close to the beginning of the universe, and you see that they're different. The ones that are in their earlier stages on the left are smaller. Those galaxies eventually merge with other galaxies and grow bigger. Their compositions are simpler. The stars in those galaxies are mostly hydrogen. Same for the more mature galaxies, but they've had generations of stars and those beautiful nebulae come and go and enrich those nebulae with heavier elements created in the fusion processes inside stars. Those processes create carbon and oxygen and nitrogen and things we need for planets and life and solid bodies, as you heard in the introduction. So galaxies have changed over time to enable what we enjoy in our own Milky Way now, which are planets and solids, and on at least one planet, life. So the universe has developed over time and continues to mature and change with the production of stars, heavier elements, and planets, providing conditions needed for life to thrive on at least one planet. This is very exciting that we understand now through the culmination of astronomy. So then the question is, does this indicate that the universe has a purpose? That we're the purpose? Aha, I have just moved from a scientific discussion to a philosophical and theological discussion. Did you see that jump? Not all scientists and not all people in the general public understand the difference between a scientific question and a philosophical and theological question and conclusion. And a lot of scientists can agree on the science, but have very different perspectives or conclusions on the theology or the philosophical ramifications. All right, I need to wind down here, but bear with me just a couple more minutes. we need to beware of what I heard, I didn't coin this term, but what's something that's called nothing buttery. Nothing buttery, what is that? Well, it's not about diet. It's about this common idea of reductionism, that we are nothing but our genes, or nothing but our brains, or nothing but meaningless random processes. We are indeed affected by our genes and our brains and random processes too, but that doesn't mean that's all we are. So, beware of these conversations that reduce who we are. Science can address part of who we are, but not all of it. I like this quote from Sir John Polkinghorne, who was a physicist and then became later in his life an Anglican priest and was the president of Queen's College in Cambridge, England for some years. He's written many books on the relationship of science and faith. And he said, science and theology are both concerned with the search for truth. In consequence, they complement each other. They don't need to be in an argument. They complement each other rather than contrast one another. Of course, the two disciplines focus on different dimensions of truth, but they share a common conviction that there is truth to be sought. Now, a lot of people in our current culture don't believe there is such a thing as truth, and yet it's interesting that side by side are scientists who are searching for truth in the natural world, and people of faith who believe that there are some ultimate truth questions. Now, these are different types of truth, but they can, I believe, also be in complement to one another. What about the perspective of faith? Can science and religion both address truth? Well, I think so. And then many of us are interested in how a biblical view of the cosmos relates to the scientific views. And I think it's helpful at this juncture to remember that in general, science is great. I love science, but science is really designed and limited to answer certain types of questions, like how does nature work? And when did things happen in natural history? And why, in terms of physical cause and effect? But our faith-related questions are generally better for, or our faith generally is better for addressing the bigger questions. Capital W, why? Why? Is there a purpose? Why is there something and not nothing? Is there a God? How do I relate to God? These are questions, how should I live, that are not well addressed by science, but are much better addressed by faith perspectives, and vice versa. And I would just note that most often in our Bible, in Scripture, nature is mentioned, especially the heavens, are mentioned not in terms of trying to tease out how old is the universe or how did it come to be, but in terms of praise for the Creator, with one of my favorite psalms being Psalm 19, that shows the intrigue of the psalmist who wrote, the heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they reveal knowledge. And yet they have no speech. They use no words. No sound is heard from them. And yet their voice goes into all the earth, their words to the ends of the world. So there's something, even today, I believe, when we learn more and more about the heavens, there's a message there. It's not given to us in words, but people around the world can be inspired by that message. And then as Christians, we go one step more personal with God, in that we believe God himself, the God responsible for the universe and for upholding it, actually entered in the flesh in Jesus Christ. And that Jesus came that we might have life and have it to the full, have it abundantly. So there's a further purpose revealed in the gospel that we can actually have a relationship with the one responsible for this amazing universe. Now, all of these interesting opportunities and challenges that are put before us by science and technology, as we look at them and as we decide what to do with our technology, what to do with our science, how to address these issues, it all involves a worldview and a sense of purpose. So what is our worldview? And what should our purpose be? So everyone in this room should be thinking about, what is the purpose for me learning what I'm learning or doing what I'm going to be doing with what I learn? And I think some of those purposes can involve service and love and humility and curiosity and hope. And I think on your little motto here involves purpose and leadership and one other word. I can't remember what it is. Thank you. Perfect. Serve. Oh, it's all there, isn't it? Isn't it wonderful? And as Christians, we have this person of Jesus Christ. Following Jesus in all endeavors gives a supreme purpose based on glorifying and knowing this person for whom all things exist. That brings purpose. It's a relationship. For the Christian, the end of studying the universe is not ultimately just physical laws and material. It's a living person who loves us. So how do we respond to this amazing universe, and how should we? Well, for one, I think we give praise and we feel a sense of humility and awe. Secondly, I think that we learn how precious our own planet is that we live on, and we should care for that planet and all of its inhabitants as good stewards, and not just the human inhabitants. God cares about the other creatures on this planet as well, and they depend on our stewardship for their well-being. And I also believe God is glorified by our continuing to have curiosity, to explore and to learn, and to share what we learn with others. So I hope you are inspired. Here's another one of these beautiful images. This one was released on the 25th anniversary of the Hubble Space Telescope. It's the Westerlin 2 star cluster. The gas nebula there around it, you can see in bright colors with little pillars that always point back to bright stars, because the radiation out of those stars kind of carves out these pillars. But there's infrared information in there as well. We can see baby stars still forming. Our universe is active. It's inspiring. I hope you've been inspired, not only to think about the wonder and beauty of the heavens, but how we can use our knowledge, our gifts, and our understanding of science and technology to serve life on planet Earth. With that, I am going to transition into a 3-minute video, which truly is the end of my remarks. And then we will discuss how what I've talked about today affects all the enterprises going on here at Pepperdine University, for which I'm very interested. So let me transition out of this and see if the miracle of technology will enable me to pull up this wonderful little video here, created by the AAAS Dialogue on Science, Ethics, and Religion.
The instant that one realizes that you're having a genuinely new thought is essentially indescribable. I'm sure that this is something similar to what people describe as a muse. It seems unworldly.
I had a little telescope I'd take up country, and everybody in the village would come out and they'd look through the telescope and see the craters in the moon or the rings of Saturn, and they'd go ooh and ah, just like my family and friends back in Michigan do. And it finally hit me. This is what makes us human. This ability to look at the sky with wonder.
When I look through a microscope, I can't help but be struck with a sense of awe and wonder about what I'm looking at. And I can't help but reflect on the larger questions of life.
The human spirit does gain a lift from pure curiosity, trying to understand who we are and where we fit into the larger scheme of things.
Because if we didn't have that sense of awe, if we didn't have that sense of curiosity, we wouldn't start down this road in the first place. It's hard to do world-class science.
When you look into something, you almost always get a surprise, and then that surprise leads you into new pathways.
Are there failures? Absolutely. When you don't have very firm grounds, you're really searching for a needle in a haystack. I collected a lot of hay before I found that needle.
It sure is fun to play in this space and to make new discoveries and hopefully make contributions that move us forward.
Science loves problems. Any fool can find the solution. It takes a genius to find the question.
We live in a world loaded with questions and puzzles. If you know how to look, you can begin to see connections among humans and other species, and between humans, other species, and the planet itself. And when you see those connections, it's hard not to be in awe.
That kinship that human beings share with all other creatures on Earth is a very, very powerful thing and helps us to understand the continuities and to place into context our uniqueness.
So we get into those philosophical questions of what is life? And within that context, what is it to be human?
There's this incredible universe that surrounds the Earth for us to go and explore, and that we as humans have to pick up that charge.
And then it becomes the task of human societies, cultures, and religious communities and philosophers to dig deep and find out what that message is that's beyond just what science is telling us. All right, thank you very much.